అందరికీ నమస్కారములు. నమో నమః. గురుభ్యో నమః. Today is the third day of our classes on Vedic mathematics. We will start the session with Vande Mataram by Challa Chittibabu Garu and Prarthana by Jayashri ji. Challa Chittibabu Garu, please.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayaj Sitalam, Sasya Syamalam Mataram, Vande Mataram. Subrajyosna pulakitayamini pullakusumita druvadala shobhini suhasini sumadhura bhashini sukhadam varadam mataram vande mataram Vande Mataram.
Vande Mataram. ధన్యవాదములండి. Let us request Jayashri ji to chant Prarthana, please.
Yes. Sir, 1 second, sir. Fan support came in here.
Okay.
Fan చాలు సపోర్ట్ చేసేస్తున్నారు. May close your eyes, sit properly, meditate for 1 minute. Three times Omkaram. Om. 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 Om Gananam Tva Ganapatigam Havamahe Kavim Kavinam Upamashravastamam Jeshtarajam Brahmanam Brahmanaspata Anashranvannotibhi Siddha Sadhanam. Om Shri Mahaganadhipataye Namaha. Om Prano Devi Saraswati Vajeebhirvajinimati Dhinamavitriyavatu. Om Shri Mahasaraswatyai Namaha. Gurureva Gati Gurumeva Bhaje Gurunaiva Sahasmi Namo Guruve. Na Guru Paramam Shishurasmi Guru Matirasmi Guru Ma Pahi Guru Jnananandamayam Devam Nirmalaspatikakrutim Adharam Sarva Vidyanam Hayagrivam Upasmahe Shruti Smriti Purananam Alayam Karunalayam Namami Bhagavat Pada Shankaram Loka Shankaram Shankaram Shankaracharyam Keshavam Badarayanam Sutra Bhasha Krutau Vande Bhagavantau Punah Punaha Ishvaro Gururatmeti Murti Bheda Vibhagine Vyomavad Vyapta Dehaya Dakshinamurtaye Namaha. Asato ma sadgamaya Tamaso ma jyotirgamaya मृत्योर्मा अमृतंगमया ॐ शान्ति शान्ति शान्तिः मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव सह ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यङ्करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः శ్రీ గురుభ్యో నమః అందరికీ నమస్కారాలు
ధన్యవాదములండి. Now let us request Gautham ji to start the webinar, please.
नमस्कार सभी को नमस्कार सब लोगों को नमः. Yesterday we completed the division methods, various methods. We started earlier with Nikhilum method, where the divisor is below a particular tens power, below 100, below 1000, and so on. Now, after that, we found that as it is becomes much away from the tens power or the base, it becomes more steps are required and becomes more complicated. So there are other methods of state division, so on, that is will be taught. Or you can use conventional, no problem, because the digits will be smaller. When the digits are smaller, you can use conventional division better. And also there are state division which will be taught in second level. Also we found some techniques we put that where suppose it is 23, it is quite away from the tens power, but 4 times of that is near to a tens power. And therefore we start with the first 4 times the tens power, that one, and then we finally multiply it by 4, so it becomes the answer. There is a particular procedure. And whereas this Paravarta method, we found that this has some divisor is little above the tens power. So here everything becomes vinculum or negative. We denote by negative, and then with the negative we handle the same way as the previous one, and then we did various examples. Where another example was there that we converted this thing that like earlier the Nikhilum method itself, we converted it to vinculum and found that I worked that out. It was also understood. Now there are some cases like again there are there are cases where it is away from quite away from the tens power. We divided instead of earlier that 23 into 23 into 4 is equal to 92. It is here the opposite. It is we divided that number, and then we with the division which is became closer to the tens power, and we worked that out, and finally we again divided the quotient, so we get the result. There some challenges came where we got half, and how to handle the half and different location. Like if it is in quotient side, it becomes a 5 in the next below position, below power of 10. And whereas if it is half comes in the quotient side, so then we have to do half the divisor. That interpretation is half the divisor. But that ultimately the thing will be both the quotient and remainder will be integer, because it cannot happen, because in reality when divided by something, we always get quotient integer and remainder integer. So this is just a step that we got the half, but finally half got neutralized. Okay, so these were understood. This example was given. I hope some people tried this thing, and if you do not, if you please try again. You find some difficulty, then please either contact me through WhatsApp. My WhatsApp number is given in the very first slide. So this we can do. Today we start with another thing. First I'll discuss the particular position. Sorry. Now today first I will discuss the particular few properties of the fraction and division process, and so this I'll discuss those things. We all know it from childhood, but it is for division purpose, for the completeness of the discussion. So far we have seen the division of a dividend by a divisor to yield the quotient and remainder. So far only we left it there. We found a quotient, we got a dividend and divisor, and we ended in the quotient and remainder. Whereas this relation between them are like this. E is the dividend, E is equal to divisor into quotient plus the remainder. This is all known to us. If we take the divisor, both sides we divide by the divisor, it becomes E by D is equal to quotient plus this remainder divided by divided by the divisor, where always R will be less than D, because if R is more than D, like we sometimes we got it during our processes, what we did, we again divided that R and this must be a smaller R, and that this contributed to our quotient. One, if suppose one more is there, so one will be contributed to our quotient. That we all know. Sometimes we even childhood, some students commit mistake. Then their mother tell that, okay, no, beta, this cannot be happen. Either one more will go or two more will go. So that way, this is always R must be less than D. We all know that. Now, depending on the requirement, we sometimes we leave it in Q and R, and sometimes we again do the fraction R by D. We write in this format, like this one, fractional format, and sometimes we do this decimal point. Decimal point, as I told, that these are the negative tens power position, but it is a more completeness kind of thing happens, because in every calculation, mathematical calculation, these are rather, do not use this. We use always decimal point expression. The expression E by D or E greater than D can always be expressed as a whole part like this, and a N by D, where now will be, instead of remainder, we'll call it N by D, numerator and denominator. So numerator and denominator are the fraction, and then then there are some properties like any rational fraction of the form N by D. This part we all know, so just for revision purpose we did. Now we come to how this N by D is, comes in a decimal format in different ways. Now the rational fraction of the form N by D becomes a terminating decimal when the denominator is purely comprising of power of 2 and 5, because our base is 10 and 10 has two factors, namely 2 and 5. So therefore it is totally, it will terminate there. So half is 0.5, 1/4 is 0.25, 0.7, 0.75, 0.125, 18, 0.37, so on. You know all that. So it is purely 10's power, 2's power, and again pure 5 power is 0.2 and 0.2 and this 0.04, like this. And when it is mixed with 2 and 5 both, there will be zeros. Like 1 by 10 is 0.01, 0.1, and 0.1, and 1 by 100 is 0.01, and so on. Now, a rational fraction whose denominator ends in 1379, not 5, excepting 5, all the odd numbers, it becomes a purely recurring decimal. Like 1 by 3 is 0.3333, and so on. 1 by 7 is 0.142857, repeating 142857. I put it in smaller than it is repeating. 1 by 11 is 0.09 and 0909 so on. 8 by 13, for example, 0.615384. 615384 again. So this is, you will find that sometimes there is the various length of the recurrence. This 1 by 3, it is a length of recurrence only 1. Only 3 is repeating. Whereas in case of 7 and 13 we got, there are 6 digits, 142857. Here 0.615384, 8 by 13, or anything by 13. It becomes 6 digits. And the 11, for 11 it is 0.09, so 2 digits. 09, say something will be the 2 by 11 will be 0.181818 and so on. So that will be 2 digits. Now there is a third category can be there, a rational fraction other than the previous 2 categories, either purely comprising of powers of 2 and 5 or their mixture, or actually ending in 1379. These will be, there is a third category other than these things, like say ending in 6, ending in say 15, not exactly power of 10, 2 and 5, but there are also 3 into 5. The 3 is also mixed here. 3 is also mixed here, 2 into 3. So 7 into 2. So with 7, there is another thing mixed. The other categories, we get a non-recurring part as well followed by a recurring part. Like 1 by 6 is, the non-recurring part I have put in red. So 0.1 and then 6. This so we call it that length of this non-recurring part is 1 here, and length of the recurring part is also 1. And here here also 8 by 15. So this will depend upon the power of 2. Length of the non-recurring part in this case, or length of the terminating decimal discussed earlier, will be the greater one between the maximum power of 2 and maximum power of 5 present in the denominator. Length of the non-recurring part in this case, or length of the terminating decimal. Both cases, it will be the highest power between 2 and 5. Maximum power of the 2 and maximum power of 5, which is the maximum of these two things, will be the length of that power. Like here, it is 2 to the power 4. 16 is mixed here. So there will be 2 to the 4. So there will be non-recurring part is 6, length is 6. Thereafter, recurring part will be again coming from the recurring length of the recurring part will be coming from, sorry, this one. Length of the recurring part will be coming from this, whether it is 7, whether it is 13, and so on. Maximum of that. Suppose 11 is 2 digits and 7 is recurring is 6 digits. So if something 11 into 7 is 77, that will be also be maximum of that, means 6 digits. Is clear? This I have not written, but this is also be written. So that is the idea. There will be always a non-recurring and recurring part, if it is other than this thing. Now, what is the transformation procedure? A fraction of the third type can be easily transformed by multiplying both numerator and denominator by either a power of 2 or a power of 5 in order to neutralize the d. 1 by 6 is 5 by 30 we do, and again we do 1/10 of 5 by 3. So this 5 by 3 will be will comprising of a whole part and a fractional part. Fractional part of the second kind, where it is 1, 3, 7, and 9. Now, because it is something is divided by 10 again, so we divided by 10. So this whole part will comprising the, when we divide by 10, whole part will comprising the non-recurring part, and obviously the other part will be comprising the recurring part. So therefore, this is transparent here that what is the property, how this fixed part is coming, non-recurring part is coming, and how the recurring part is having the same property as the 1379, what is stored there in. That basically third type fraction results from a whole number added to a recurring fraction of second time, that is d ending in 1379, and then the whole expression divided by a power of 10, like here in the case. More examples. 29 by 74 is equal to 145 by 370 and 1 by 10 of 145 by 37, and 145 by 37 is 3 plus 34 by 37. So basically it is this 3 and 34 by 17, 3.3. I already worked it out, and then 34 by 17 divided. So it is 918. 918 is that 34 by 37 is 0.918 repeated. So it becomes 0.3 and 9189. This by 75, which is power of this. There are 5 to the power 2 is there. 25 is there in between. So there is a 3. We multiply both sides by up and down by 4. So here becomes 116, 29 into 4, and this is 79 into 4. 75 into 4 becomes 300. So in 0.01 means 1 by 100 into this 1 by 16 by 116 by 3. 38 plus 3 by 2 by 3, so 0.38. Non-recurring part becomes 2 automatically, and then it comes to this one. Opposite, if you, the procedure for opposite, for terminating decimals, denominator becomes 1 followed by as many as zeros as the number of digits of the decimal point, then write in the minimized form, that is if required. 0.1 to 5, so as many as many zeros I write, 1 followed by as many zeros. I converted it into integer, and then I write 1 followed by 0 and divided that by it. When I cancel it, becomes 1 by 8. 5.48. This actually becomes two digits, and then 137 by 25. We cancel it by 4. For pure recurring decimals, put as many 9s at the denominator, as many number of digits recurring, then minimize. 0.3333, 3 by 9 is 1 by 3. 0.4545, 45 by 99, then becomes 5 by 11. 1.142857, 1.142857, we'll find that 1.42857 followed by, there are 6 lengths, 6 recurring lengths. We put 6 number of 9s below, and we cancel that. We find that it is 1 by 7. Whereas if it is mixed kind, what we do? For mixed kind of decimals, in that denominator, put as many 9s as the number of recurring digits, followed by as many zeros as number of fixed digits on the numerator. Subtract the fixed part from the total. On the numerator, what you do? In the denominator is fine. It's as many 9s as the recurring digits, as many zeros as the number of fixed digits. And on the numerator, what you do? Subtract the fixed part from the total. For example, 0.1666 and becomes 16. Total I do 16. And then minus this recurring part, 1. Then divided by as many zeros. Both are here, 1 recurring and 1 recurring, 1 non-recurring. So 9 and 0. So here 15 by 90, 1 by 6. 0.6818181. So sorry, 681 minus 6 divided by 818181. So this 81 is 2 digits are recurring. So 2 numbers of 9, 2 9s, and then 1 is fixed. So this 0, and then becomes, we cancel it, becomes 15 by 22. Cancel by 45. 0.153, 1.15, and then 323, 323. That's right. So 15323 minus 15, and then 2 numbers of this, 3 numbers of recurring and 2 numbers of non-recurring zeros. So then again, so this whole thing, this is worked out by 900 and becomes 300. Now, by Nikhilum method, we can also do like what we do in order to evaluate a fraction. What we did from childhood. This all we know actually. These are for revision purpose from our childhood things. Now, for evaluating this thing, what we do? We put a decimal point, isn't it? Like for example, I do 1/4. I divided by 1 divided by 4. I did like that. And first we put 0. And then, sorry, 4 into 0 is 0, because 4 into 1 will not fit here. So 1 becomes element. So that is the first step. We find that there is 0 and 1. This must be, we must remember, we directly should not put 0 and put a 0 here, put a decimal 0 here. This is the first step. You must remember, first we get that 0 as my, if it is less than this, if the dividend is less than the divisor, first we get a 0. We should not forget that, because sometimes people skip, and I have found that even very higher expert in mathematics, they also commit the mistake. They will tell fraction, they will tell the decimal point. It's not. First it is that answer is, quotient is 0 and the remainder is something. Like here you put 2, 3, here also you will get 2 and 3. 4, if I put 4, then of course it will be 1 and 0, 1 and 4, and then the remainder will be 0. Not that. Here it is 0 is the quotient and 1 is the remainder. Now, when you this is the integer division stage. Then what we do? Put a decimal point. We want to push it further, and we put a 0 here. Now comes again, we call 4 to the 8, and then we get 2, and then we continue, because this, since the decimal point is already there, we don't have to put decimal point in every place. That was taught to us. And then we found that we automatically put a 0 here, because the decimal effect of the decimal point is there, and the 4, 5 are 20. So this is just a revision that what we do like this, and finally you get a 0 here. So this is the terminating decimal, because it terminates here. In case of 1/3, what will happen? So again, we first put a 0 here. We find a remainder, that is, it is 1, and then put a point, and then we put a 0 here. We do 3 here, and then we write here 9. Then again we find that again 1 is coming. So therefore, again we put a 0, again 3 will be there. So we write that again, that's the 9, and no point to understand that. Therefore, we put a is equal to, we write 0.3 and it is dot. So we all remember this one, isn't it? So this is the idea. This, then I showed here that in the Nikhilam also it can be done. 3 by this one, this 6 came here, and it came actually the 3 into 2, 6 came here, 6 and 0 again came, and then so it is again we put 0, and then we found that it is this 6 into 2 is 12. The 6 was in the remainder. So remember the procedure. 12. Then 12 again. This thing came. 12 minus 8 is 4. That's so 12. This one 8 into 7. This came. This one actually comes to 7, and then 4 becomes this remainder again. So again put a 0, and that way we do it at 3.75 grams. That way, this also, like here also I evaluated this one. Now see that both of the either this one or both this one becomes at times very complicated. Like if we do for 1/19, like 19 if I do for example, 1/19 I do. Now 0.0, and then it comes like this 1. So point comes here 0, and again it is less than this, so again put another 0. We did that 0. Now we come 5. and 95. It comes 5. Again, we put a 0 here, 2 here, and 38. That way it goes. And this has recurring length is 18. This recurring is how much? 18. So this becomes very complicated. So suppose somebody is asked, some student is asked to evaluate how many fractions is possible with 19 as a denominator. With 19 as a denominator, how many fractions possible? What are the possibility of remainder? Please tell anybody. 2 by 19 can be. Then how many? Comma, how much? 18 by 19, no? Suppose somebody asked to evaluate all these things. Remember, all of them have evaluate up to the end, up to the recurring, seeing that how much, where it is recurring. Somebody asked to do that. Then what will happen? 1 by 19, 2 by 19, up to 18 by 19. So it will be 18 times you have to do with 18 into this, 18, 80, 18. So that, sorry, 4. 324 steps one has to write. This somebody wants to evaluate all the recurring, total recurring, seeing the recurring, where it is recurring for the fractions 1 by 19 to 18 by 19. How many have to write? How many such evaluation, how many such calculations have to be done? 324, 18 in each of them. Now, therefore, this is not the proper procedure, either Nikhilam or the conventional one. Here we come the basic online method. Okay. So I want some reaction. You got the problem, no? You understood the problem situation? Any reaction? Anyone? No reaction? People are listening. I'm audible.
Yes, sir, we are listening.
So these were just a revision. These are all revisions. But anyway, revision also is good sometimes. People gain something out of today's discussion up till now. Please tell me. The concept of terminating decimal, then pure recurring, and mixed recurring. You got it something? And the conversation between these two. Please tell someone please, any participant please do tell that yes, you got it, or didn't get it. Kindly repeat something like that. Then actually I can. Then you will be understanding. You will enjoy the, the whatever actually today's topic. You will enjoy that thing. That how it is different from the others previous procedures. Okay, should I proceed then?
Yeah, just a minute. Babu, I think they are some
Yeah.
people
Please,
wanted
please
to be
unmute.
unmuted.
Then.
Yeah, they wanted to be unmuted so that they can talk.
Yeah.
Babu Garu?
Yes, I'm doing.
Right, okay, thank you.
So please unmute and talk.
Sir, good morning. Thank
Good
you very
morning.
much. I think it was clear.
Your
Okay.
video also, please.
Especially the-
Your video also should be on. Then I can see you.
Can you see me now? Hello, Gautham ji, sir. Can you see me?
Let me see. Yeah.
Thank you very much. I think we understood all the different three types of recurring terminating and recurring, and then pattern decimals. What I am not clear is we just divided the 30 by 8 using Nicolum method. Okay, so that comes as 3 6 by 8. But how did you convert the 6 by 8 into a fraction 3.75? I'm not clear. Was that covered, Sama, or we going to cover it now?
Which one?
No, that 30 by 8 division using Nicolum method we did right now. Okay, and in the next slide.
In this slide?
In this slide. We just did that. Next slide. Next slide, please. Next slide.
Oh, next one.
Next one. We just next one, sir.
This one?
नहीं, further up. उसके आगे. 30 by we just did that. Basically, how do we yesterday we learned how to divide using Nicolum. Let's say 30 by 8. Okay, with the remainder as a fraction, but not as a decimal. Yes, sir. Yes.
Oh,
sir.
here. Yes.
How did you get this 3.75?
Yes.
30.
So here actually this is the details. See, first we got 3 and 0. Suppose 30 we are dividing by 8. Okay.
Now I know up to 3 6 by 8. 3 6 by 8 तक मालूम है.
3 is the my
it will go
3
down.
is my quotient and 6 becomes my remainder.
Correct.
So this is the 3. Result becomes 3 point. That's all. But while with point, I am putting a 0 here. I am allowed to put. Earlier this result was 3 as quotient and 6 as remainder. But what we do with remainder in this procedure also it can be done. So result was 3 point, and then 6, and then put after this putting the point we put a 0 like we did earlier. Now again the 6 into 2 is 12. Now 6 becomes my 6 becomes my quotient and 12 becomes my remainder in the first go. But 12 remainder is not possible, so we simply do minus here. Or you can do 1, 2, that way also can be done. 8. I can do 1 into 2. This 2 is here. So 4. So 1 and 4. That 1 contributes towards the quotient. 6 plus 1 became 7, and the 4 remains my remainder. Because of the decimal point effect, so 3.7 becomes my up till now the result. Again, the 4 remains, and the 4 we because of this effect of the decimal point, we put another 0, like we did earlier in our conventional case. Again with 4 to the 8 comes here. This 8 actually contributes, becomes 0 and contributes 1 towards the quotient side. So 4 plus 1 becomes 5. That way it becomes a 3.75. I skipped it. Good that you helped me there because I skipped it. It's good.
Okay.
You are
no problem, sir.
That way, whatever we did in conventional method, like we put a 0 point and do 0, and then effect of the 0 effect of the decimal point comes. Always put a 0 in the remainder. The same thing can be done in Nicolum method also. Like this also I have shown, and I really arrived at that particular point, which is 142857. This pattern I got when dividing by 7. 22 by 7. Like we know that 22 by 7 is the approximation of very crude approximation. 22 by 7 is 3.14. actually 3.142857.
17.
I would like to divide. I would like to deviate slightly. It is very my interesting subject. This is a very bad pi approximation. I should tell you. You should tell this message. You should spread everywhere. That 22/7 is a very bad approximation. Whereas, please note down. This is not the part of Vedic mathematics, but actually, please note down. 355 by 1 by 113. You could do it like this. (355) divided by 113. It actually becomes is equal to 3.14
1.5.
159 29204. Whereas actual pi is this, and actual pi is 3.14159. We remember something we got memorized, or 26536. So you see that there is a difference in here only. Something like, say, 3 crudely this one 3 into 10 to the power minus 7. The difference is. Where it is dividing, it is getting different in this third division, third location itself. Here it is getting different in seventh location, sixth location. Sorry, seventh location. Seventh position of decimal point. Here it becomes third position itself, it became different. So anyway, that is just a diversion.
So basically what you are saying is 22/7 is not a real pi.
No. So better to use 355 by 113 always.
I see.
Okay.
Thank you.
Now we come to our today's topic, actual topic. So we found the problem, no? That suppose somebody is asked to write, there are 18 kind of numerators possible for denominator 19. One, of course, 1 minus d. So 1 by d up to 1 by d up to d minus 1 by d always. These many fractions becomes possible when you with a particular denominator d. Like 19 in this case, we get 1 by 19 to 19 minus 1 is 18. 18 by 19. So, and these are recurring up to 1 less than that. Recurring length is 18. Like in 7, we got 6 recurring, 142857. Here it is 18. So, remember, imagine somebody has to find all these things. We have to do 324 calculations here. 324 times 19 into 19 into 19 into like this. But here is C. Now you'll find the beauty of this thing, Vedic online method, which I'm going to teach. This is called recurring decimal. These are the best procedure for evaluating any recurring decimal is the Vedic online method. So first we start with the denominator ending in 9. So these are the form 9, 1 by 90, 1 by 29, 1 by 39. I didn't write it by 1 by 39 also. It has slightly different property, therefore different because it is composite number. So this fraction like this. So this becomes very cumbersome either in conventional method, the conventional method, or the Nichilam method. Both the conventional method and the Nichilam method fails here, you can say. So Vedic online now method comprising of ekadikanu purveno, this one we do. And then Vedic online method is directly applicable to denominators ending in 9. Others actually you have to multiply both this one by suitable things, like in case of ending in 1, you have to do by 9, 1 into 9, and 3 into 3 is 9, 7 into 7 is also ending in 9, 49. So that way you have to multiply both denominator and numerator to get this one. So first we'll start with 1 by 19. Although it is length is higher, but actually it is the divisor is very less. 19 is the very smallest number you can say in that thing, except 9. Instead of dividing, now this is very interesting. First you remember this one. First you understand this. Instead of dividing 1 by 19, we shall start dividing 1 by a digit divisor. This is not the divisor actually, it is a digit divisor, which is what? Now d plus 1 divided by 10 is equal to 2. Or you can say, also come the ekadikano purveno 19. So 9 purveno of 9 is 1. And ekadikano, this 1 plus 1 is equal to 2. 1 plus 1 is equal to 2. So ekadikano purven. So ekadikano purven is, so here digit divisor is 2. So divisor is 2. So what we do? So we start like this, start dividing by 2, put a decimal point. So what we do? Put a decimal point. Then now 1 divided by 2. You tell me if I do not put that, anybody have any confusion? 1 divided by 2, sometimes people directly jumped into 0.5. But no, I don't want 0.5 because 0.5 came when we followed a procedure, namely after putting a point, put a 0 on the remainder. So remainder first came. Remainder first came here. It is not that directly we put a 0. So suppose we do 1 divided by 2. Here I show 1. I am dividing by 2. Okay. It is not coming. Directly we do not put. We do not this after putting the decimal point. We do not put a 0 directly here. It is not. This is not the proper procedure. Proper procedure here. What is that? 2 into 0 is 0, and then 1 comes as a remainder. This all is this you remember. So when we 1 divided by 2 gives, and after that, this is the next step. After putting a 0, you get the 0, and then then comes 0.5. 0.5 comes much later. Then we do 10, and then it becomes 0. So 0.5 comes much later. I again clear. So when 1 divided by 2 gives quotient as 0 and remainder as 1. This is my remember. And then therefore we write, what you do? With quotient you write like this. So quotient was 0 and remainder is 1. Now this looks like it's slightly below, right? Below and left we write. So this looks like 10. So now 10 we divide by 2. It's 5. If we write 0 and 1 like this, it looks like 10 like this. So that is the tens digit we write. 5. So please, side by side, you also write on your paper. Please. Therefore I asked you to carry paper, pencil, everything. So if you commit any mistake, you erase by eraser. But you please follow this. This is very important.
Guruji, can you start right from starting from?
Starting from, yes. Okay.
So that right.
Yes. So obviously it will be 0 point something, not 1 point something. So instead of just put a point, I prefer that there should be 0 also. 0 point. This is 0 point. And then 1 divided by 2. 1 divided by 2 in a special format. Instead of 1 by 19, we do ekadikano purveno 1 divided by 2. So when I divide by 2, what happens? 0. Actually, my house is near a highway, so sometimes you'll get these horns and so on. So am I audible? Apart from the horn and so on?
Yes, sir.
Audible.
Achha. Now 0 becomes my quotient and 1 becomes my remainder. You write slightly below and left, and then you look like this. So it becomes 10. 10 divided by 5. 10 divided by 2 is how much? 5. and no remainder. Sometimes no remainder, you can write 0 also, or may not write also. Just do not write anything here. Do not write. Erase it. Erase. I erased. See, it is also possible to erase. So 5 divided by 2 is how much?
0.5.
Huh?
2.5.
No, please do not. Again, I tell you, always tell in the form of quotient and remainder. How much quotient, how much remainder?
2 remainder.
No, 2 quotient. Instead, when dividing by 2, the remainder can be either no remainder, means 0 remainder, or 1 remainder.
One.
So
One.
here,
1 is the remainder. 5 by
1 is the remainder. Now again, look like this. It is looking like what?
12.
12. 12 divided by 2.
2. 6.
Always divide by 2. Continuously dividing by 2.
6.
12 divided by 2?
6.
6.
With 0 remainder.
6, no, 0 is not right. 6 divided by 2?
3.
3 divided by 2?
1 remainder.
No, first you tell quotient.
1.
1 quotient and remainder
1.
1. We look like this, then what happens?
11 divided by 2.
11. 11 divided by 2?
5 and 1.
5 and 1. Now it will be, you will see that when you understand, it becomes faster and faster. Please, everybody participate. Everybody please start writing. Maybe that you please advance with me, but more advanced than me. Then I will catch up with you. 15, isn't it? Then
7 and 1.
7 and 1.
So that will be 8 and 1.
8 and
1.
8 and 1. There is no place, so I write here.
4. 4 and 0. 0
No.
is 4.
It is not 8, it is 18.
Yeah.
So?
Oh, 9. Sorry.
9.
9. Correct.
9. Then next step?
4. 1 and 4.
No, 4 and 1 you do. First quotient, then
4.
remainder.
Okay.
But
4 and 1.
4 and 1. But 1 you write this one, that becomes 1, 4. 14.
Yeah. Correct.
Not 41. Please do not commit mistake that quotient you, 10th digit is the, remainder is the 10th digit. And there is a scientific algebraic explanation of this. This is not just like that. This is not just ended in somebody, discover some trick and it is called basic mathematics. Not that. It is a rigorous method, but it is converted into procedure. We knew that particular thing. We knew the algebra of that. But in modern mathematics, people never thought that, because this Sanskrit teaching was banned in 1817. Actually, I think this was told by C.S.R. Prabhuji several times, or other teachers also, that we are very unfortunate that from our education system, all the Sanskrit texts were totally removed, and all the treasures were there somewhere. They caught up only few of the procedure, and they in the world those are going on. The others are not translated into procedure. Their algebra is known, but it is not translated into procedure. Now it comes, what is the next step?
Next is 9.
7.
7.
7 and 0.
No remainder. Then
7.
quotient remainder.
You have to keep saying
quotient
fast.
0.
7, 0, 3, 1. So
3 and 1. Yes.
As you say it faster, you will know it faster. Others also will know faster.
So
Six.
3 and 1. So when I look at slightly my tilt towards left. So then becomes 13.
13.
13 and divided by 3 is
6.
divided
6
by 2
and
is
2.
6 and 1.
6 and 1. This becomes
16. 16. 8. 8 and 0.
4 and 0.
then
4
4
0.
and 0.
4 0.
then
2 and
2 and 0.
then
1 and 0.
so in parallel everybody all the participants did it together.
Yes.
Yes. So this is the procedure.
sir.
Now then what happens? Then after 1
Again, if 5.
exactly. We started with 1. That mind it. We started with 1. We got up with 1 and the same kind of remainder, either 0 or whatever. Suppose we started with 11. Had we started with 11, if we get 1 quotient and 1 remainder, that is 11. That means again we will get the same result. So what we do? We put a
Recurring.
bindi here, dot here, and a dot here. So this is my result of the recurring decimal.
Hmm.
Okay. Now see. Now you see very carefully. You also did like that, as I did, broken it into this part, say 9 and 9, 9 in the top and 9 in the bottom. I told that there is no place, right? But actually there is a purpose behind this. I knew that it is ending in 18 digits. So I halfway, I broke it. Say 0, 5, 2, 6, 3, 1, 5, 7, 8. Total is 9
Gautam
numbers.
ji.
Again, 9, 4, 7, 3, 6, 8, 4, 12, 9 numbers. Total is 18. Total is equal to 18 digits, isn't it? 18 digits. Now,
Gautam,
do you find any
Oh,
interesting
calendar
things in
ne-
this?
yeah, Gautam ji, just a minute. After
ఓ మాట చెప్పు ఏదైనా
1,
వేస్తాను.
there is again, it is 1 becomes 5 and 0.
1 becomes 0 and 1,
Okay. Then it is 5 and 0.
5 and 0. After that, it again becomes 2 and 1. Again, it becomes 6, 3, like that. It repeats.
Right. Okay. 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 Thank you.
So now you find any interesting point between this? See, add up here, add like this, add like this. What is the addition of these things? Corresponding digits.
All are 9.
All are becoming 9. And the remainder, suppose we add up the remainder. What is the remainder adding?
1. Should be 1 only.
And 1 is that digit divide. 1 is this one. This one.
Yeah.
So Ekadikono Purbana did added with to this one to 2. Again we got to this remainder adding up to 1. So this particular one is that one. Whatever is the below before 9, that number it came back as the addition of this remainder. So you see that I could have done. Suppose I know that this kind of properties of these things. I could have done halfway, and just rest one just reproduced by dividing the subtracting the quotient from 9 and subtracting from the remainder from 1. So that way, wherever there is a 0, there is 1, there is a 1, so this is 0, and so on. So this is one property. And then third one is that I will tell that earlier what it did. Earlier I told you that suppose somebody is asked to do this 1 by 19 to 18 by 19. All are 18 digits length, and then 18 times you have to do that. So total 324. 324 times you have to do the calculation. But here see, you did this calculation. I will tell that this contains all these answers. 1 by 19 to 18 by 19, all this answer is there in the one line. I challenge you. You tell me, you explain, then please look, you understand this, try to understand. Why? Okay, so suppose please somebody give another by 19. I did it 1 by 19. Suppose please tell another number by 19.
3 by
Anybody?
19.
Huh?
3 by 19.
3 by 19. Now, where is 3 found? What is 3? 3 is here. 3 is here. This is 3. This is my 3.
So, okay.
Now, suppose I start with 3. What will happen? 1 quotient, 1 remainder. Again, 5 quotient. So, with 3 by 19, the result will be 0.1578 94736842 then comes back to 0, because it will, next steps will be 0. No, here it comes. We didn't write, but actually recurring means it will again put it. It will come back here. 05263. It will end at 3. 3 by 19 will end at 3. Ends in 3 only. Ends in 3. Ends in 3. Here 1 by 19 ended in 1. End 1. End by 3. So you understand, no? Please tell somebody, you didn't follow. Yeah. So 3 by 19 will be 0.1578. Then below 94736842 then again above 05263 end in 3. Anything else? Anything other than anything? Another one by 19?
5 by 19.
Huh?
5 by 19.
5 by 19 is 0.263. 5 is here. Here is 5. 0.2631578 9 and so on. Then up to 21 and then 0.05 ends in 5. 5 by 19 ends in 5. Ends 5. Then you please tell another 2-digit number.
11 by 19.
11 by 19. 11 by 19. Where is 11? Where is 11? Can you find 11? 11 is here. See, this was 11. 11 means what? 11 means 1 quotient, 1 remainder. 11 means 1 quotient, 1 remainder. So result will be 11 by 19. You can verify whatever I'm telling or whatever you also tell. You can verify side by side with calculator. So you'll find in calculator will display only somebody, even the mathematics professor, they told, what will do it with this? Now calculator is the fastest one. See, calculator will display only sometimes 8, sometimes 10 digits. But here it will not show all the recurring digits. It will never show. Moreover, this property will not be shown in calculator. So this is the power of the Vedic mathematics. It is much more than calculator, something more than calculator, not in terms of speed, but in something else, understanding something. So 11 by 19 will be point. Please tell me, somebody.
578.
94736842.
1. Then
05263.
05263.
1. Ends in 1, but remainder 1. This ends in 1. This also ends in 1. Ends in 1, but with a remainder it dips. Remainder is also 1. So this is the 11. So you got it. You got that. So another property. This is how many properties I told. First I told that once you do, everything is already there. All the 8 instructions. Number 2, if we do it halfway, whatever you tried, you start with. maybe you start with 3, 8, 5, 11. Whatever you start, if you break it halfway, it then adding up the half components will be adding to 9 and remainder adding to 1. That is this property I told. Another property is there. I could have started from right to left. And with right to left, somebody wrote a paper without somebody wrote a paper on this. And this will be accepted because people don't know these things. The world doesn't know these basic mathematics techniques, such techniques. So obviously, suppose somebody writes a paper on all the basic mathematics techniques, and it will be accepted. It will be accepted as an original work. Because the evaluator, all the papers, the paper who evaluates and then put the paper on the publishes the paper, the publishers, they are not aware of the basic mathematics procedures. That is the unfortunate part of it, and we are deprived. And we also since in the so much in after independence also so many years, we are still deprived of these procedures. Now tell me. This right to left, I'll discuss. So suppose 1 by 19 have to do. So start with 1, multiply by 2. 1 multiplied by 2 is 2. 2 multiplied by 2 is 4. 4 multiplied by 8 is 8. And then 8 multiplied by 2 is 16. 6 I write on the top in the quotient line, and 1 I write as remainder. Again, next step, 6 into 2 plus 1 is 13. 3 I write here, and 1 I write, 13 I write 1. It's just the opposite. Whatever is remainder from left to right is the carry from the right to left. This carry we put in the this part. Again, 3 into 2 plus 1 is 7.
7.
7 into 2 is 14. 14 4 I write here, carry I write in the left. 4 into 2
4
plus
into 2,
1 is
8
9.
plus 1, 9.
9 into 3 is 18. 8 into 1,
18.
8 into 2 plus 1, 17. 7 into 1, 7 into 2 plus 1, 15. That way goes, and get 5 into 2 into 2 plus 1 is 5. 5 into 2 plus 1 is 10.
10. 10.
0 and 1. Again, 0 into, 5 into 2 is 10. And this 0 into 2 plus 1 is 1. Backs to the rightmost, what we started. Everywhere you do, wherever you start, it will be just because this is the whole procedure. So whatever you starting doesn't matter. You always get the same kind of things. So this is the idea of the basic online method. So these are discussed. This is much better than we discussed it. I just revised it. It is put on the slide also. Successive quotient and remainders in the form RQ. This dot Q and R. We write in this format. RQ are as follows. From the beginning of 1 by 19, remainders are written left in small. So 0 point, this 0, 5, 2, 6, 3, and 1, and 0, and so on. I put 0 here explicitly. So this I already evaluated like this. At this 18 digits, we again arrived at 1 from where it started. The sequence will be repeating this one, and this is this. Oh, sorry, and this is this and this. Regarding this 18, and then it's possible. I have shown you everything, so just it is written so that you do not forget it. The same result could have been done right to left by starting with 1 and multiply by 2 every time. So 1 into 2 to 4 to 6 plus 10 and so on. In case of full cycle, mind it, full cycle is when full cycle comes when this is full cycle comes when this 19 is minus 1 is equal to 18, and so 18 is my recurring length, and this is 19 by just 1 below the 19, so it becomes a full cycle, 18 cycle. So this becomes half length becomes 9th complement. I told you that adding to 9 digits other than the half length. Thus, after evaluating 9 digits, we could have gotten the rest by subtracting them from 9 please see above, or please note corresponding remainders also added to 1, which is digit divisor minus 1, all the or that ekadikono purbeno, that purbeno has to there. Now we come to anything n by 19. I already discussed this full cycle. So this actually becomes, we know the sequence by the observation. Whatever I told you that it can observe it, it's called Biloconum observation, and say 9 by 19 will be 9 by 19. We have to find where is 19. This was actually this was actually 18, not 8. 8 is here. 8 is here. It is 18. I didn't write it actually here. So this is my 9. So 9 by 19 will be 0.47. So it starts with 0.47 and ending in 9. 0.4736 and so on. So this is the synchronization, but starting point is different. Check 9's complement property also. After writing this also, I can write that. I can say that this is also has the 9 complement property. I break it away. Then 4 and 5, 7 and 2 and so on. Corresponding adding to 9. Like obviously those same numbers are recycled. Not recycled. So exercise guess for this one. We all can do it now because already we did it. These things already evaluated, you can say. Now come to 1 by 29. So 1 by 29 or something by 29. What happens here? Is equal to 29. Ekadikono purbeno. Purbeno is here. Ekadikono is how much? What will be my digit divisor?
3.
3. Exactly the same way you did. With 0 point, we start with 0 point. Then 1 divided by, we do 1 divided by 3. So when we divide 1 by 3, 0 becomes my quotient and 1 by remain. Always remember that anything divided by 1 divided by anything will always quotient will be 0 and remainder will be 1. That is the thing, obviously. Then becomes 3 quotient and 1 remainder. 13, 4 quotient, 1 remainder. 4 quotient, 2 remainder. 8 quotient. That way, you can also side by side. Some of them can write yourself, try to evaluate. You will find that it will go like that. After 14 digit, if we fold it like this, you will find that this adds, this quotient adds up to 9 and remainder adds up to 2, which is this 2, 29, 2, or digit divisor minus 2 again, minus 1 again. So this thing. Should I go step by step or you understood?
Understood.
Huh?
Understood.
Got it, sir.
Got it, no? Yes. So this will be just repeating. Instead of dividing by 2, we are always dividing by 3. And similarly, starting from by Biloconum, here suppose somebody was asked to, I'll tell you how many calculations have to be done. The recurring length is 28, and there will be 28 such fractions. Suppose somebody is asked to do 1 by 29, comma 2 by 29, dot up to 27 by 29, comma 28 by 29. Total 28 such fractions, and 28 such fractions, and those either by conventional method or Nikhil method, do that put a 0 and again tables of 28, always, and do these 28 steps in each of them. Is total is 784. 784 calculation one has to do. Now here, how many calculations you are doing? How many calculations you are doing? We are doing 28 calculations.
28.
Only 28 calculations. 28 times you have to do, finding the quotient and finding the remainder. You understood? Huh? This is we are deprived of such a technique from our childhood. It's very unfortunate. Any children are there with anybody? I asked it. I told you that this, please take along. Anyone having a children of say class 6 to 9? It is very interesting. They will find it also very interesting. Anyway, you can if you have learned it, then you can discuss with them. I found that some people who are in a puja mandap, some people who are just some children, of course, small child, they are just running away and do this thing, that thing. I took a paper and pencil and then I started doing this. They were so much interested that they become calm and quiet and started learning this. Very interesting. You also do like this. After learning, you do something like that. You, in a group of children, you throw it. It will be very interesting. Anyway, okay. So here I got like this. So by Bilokonam, you can do anything. All these fractions, 28 such fractions with 28 length, 6 by 20, for example, 6 by 29, I'll start from here. 11 by 29, I'll start from here. That way we can do. And then now I proceed. Anything n by 28, 29, you know already. You can, some of them you can do. Now come to anything n by a9. So I told that is 59. I found the 59. So digit divisor is 6. So 1 by 6, 0 and 1. Now 10 by 6, the 1 quotient 4 remainder, that goes, and the length is, recurring length is 58. This I did by, there is a procedure in Excel sheet, Excel. Anybody is interested in Excel, this is not, I can tell you, and show the Excel sheet and what is the expression to be written. I can tell that so that you can just drag it. Anybody expert in Excel can know. If just expression you drag towards right, it will produce all these things. It will be very easily and much more than calculator. Calculator will produce up to 10 digits, up to here it will write. If you do 1 by 59, say what I'll show you. I will just verify how many digits it is doing. 1 by 59 or something by 59. Suppose 10 by 59 will do. So one more signify here. 0.16949152554. 0.16949152554. It cuts up to here. And 1 by 59 will cut here. So 10 by 59 it becomes displayed up to this. It will not display up to 58 length. So, but the Excel sheet with the proper formula, if you drag, it will to any length of recurrence, it will drag. Now come to what is the procedure? What is the algebraic? This I must discuss before. Still time is there. Algebraic procedure is like this. How many people understand this algebra of binomial expansion?
I understand.
One small doubt.
Which one?
Why always you are taking this one 19, 29, 39? Or can it be done for the other numbers? And what is the use of taking 1 by 19, 129, 1 by 29, and like this?
See, I shall discuss it. Other denominators. For other denominators, 1 by 7. I converted it into 7 by 49 first. Then it is ekajikono purbeno of 9 becomes 5. So 5 divided by 5. So I start dividing 7 by 5. Then 1 becomes my quotient and 2 remainder. When I divide 7 by 5, 1 quotient, 2 remainder. 21, 4 quotient, 1 remainder. 14, 2 quotient, 4 remainder. 42, 8 quotient, 2 remainder. 28, 5 quotient, 3 remainder. And then 7 quotient, 0 remainder. Comes back to 7. So this is 142857 is my, again that is full cycle because 7 minus 1 is 6. 7 was my denominator. This is 6 length. Here also 9's complement. 1 plus 8 is 9. 4 plus 5 is 9 and 2 plus 7 is 9. And also from 1 you can get all these things because suppose you want something else by 9. Suppose 4 by 7. 4 by 7. 4 by 7 will be how much by 49? So 7 into 28 by 49. It is 28 by 49. You must end it 9. 49. 28 by 49 is 40. 28 is here. So in case of 4 by 17, it will be 0.571428. Okay. Yeah. In case of 13, 13 is a different 39. It doesn't add up. No, where I somewhere else I found. That doesn't add up into 9. Anyway, this also adds up in 9. So similarly, 13, something by 13, it becomes 3 by 39. So start with 3 and remainder 4. So it becomes 0.0, 0 remainder, 3 by 4. So 0 remainder and 3 quotient, 30, 7 quotient, 2 remainder. But okay, I can cover it later, but today I cover remaining time. Let me so you understand something now, that any quotient is possible. You have to multiply by appropriate number to make it 9 in the end. Why 9? Here the algebra will tell you why 9. So now I start with algebra. That will answer your question. There also I answered the whole procedure. If it is not 9, what to do? But not that. You are telling that why only 9 we are considering. This is the result is this. Now, how many people, cause is this? How many people understand binomial expansion?
I understand.
Yes. You did earlier, remember that a plus b whole square?
Yeah.
This
Binomial
is
form.
understood by everybody. So we do it. A square
Plus 2ab plus c square.
AB. Now instead of that b, suppose I write 1. B becomes 1. So 1 plus a whole square. This was 1 plus 2a
2a
plus
a square.
a square. Similarly, all these things are there. There is a permutation, combination kind of things. If somebody understands, they will understand this particular coefficients. Is called 1, 2, 1. 1, 2, 1. Now a plus 1 plus a whole cube, it comes from a plus b whole cube. So it is also 1 cube plus a square a cube plus 3 a square b plus 3 ab square plus
Plus a cube.
b cube. So 1 plus 3a plus 3 square, considering b is equal to 1, plus a cube. Coefficients are 1, 3, 3, 1. Because basically the 1, 3, 3, 1 is 11 cube. The 1, 2, 1 is 11 square. So this is the idea, and for to the power 4, it should be again that coefficient will be 1 plus something a square, a cube, and a to the power 4. The coefficient will be 1, 1, 4, 6, 4, 1. It becomes like it is again 11 to the power 4.
4.
It is 1, 4, 6, 6, 4, 1. That way it goes actually. Now the challenge comes when this with minus, of course, it is same thing. Minus, it will be alternative. It will be alternative. Instead of a minus b, it is suppose it is a minus. Sometimes it is written like that. A 1 minus a whole square, 1 minus 2a plus a square. We write something plus minus also. When minus, if minus is there, you always follow minus. 1, and then alternatively this minus, this remains plus, this remains minus. Wherever there is a positive power, it remains as plus. With negative power, it becomes changes the power. Here also plus minus. This way that goes. Now the challenge comes when instead of positive power, we do a negative power. See, what is 1 minus x to the minus 1? But it will be applicable when, sorry. It will be applicable only when x is less than 1. Okay. So it is like this. I erase it. 1 minus x to the power minus 1. 1 plus x square plus x cube plus x to the power 4 plus goes. Somewhere x to the power 100 will come, plus, dot, x to the power 1000 will come. That way it goes. So I can express it this way also. 1 plus x common, 1 plus x common again, 1 plus x is less than 1. So 1 by 29, 19, 1 by 29, a by 9, which others cannot be done, is that 1 by 10n minus 1. This 1 is important. Instead of suppose you do 17, it will be 10n, 10 times 2, n is 2. So 10n minus 3 it will be. It will be very difficult. It will not be done properly. It will be cumbersome and not properly as easily understood as this. So this can be expressed as 1 by 10n minus 1 and 1 by 10n 1 minus 1, 1 by 10n, I put it out, and 1 minus 1 by 10n to the power minus 1, where this becomes less than 1. This becomes less than 1. Because it is 1 by 20, basically 1 by 20. So I am basically converting the 1 by 19 in terms of 1 by 20. n is equal to 3. In case of 19, n is equal to 2 here. Because 10 times n, 10 times 2 is 20, minus 1 is 19. In case of 29, n is 3. And that becomes my digit divisor. That is the mystery behind ekadikanu purveno. 10 times 3 minus 1 is 29. So that way, suppose I put 10n here. So 10, again 10 and these things. You don't get confused with n. You could have written as well. Suppose you make it, in case of 19, make it 20. 1 by 20. 1 by 20, 1 by 19 is 1 by 20 into 1 minus 1 by 20, 1 minus 1 by 20 to the power minus 1. So take it out, 1 by 20, 1 plus 1 plus this 1 by minus 1, 1 by 20 plus 1 by 20 square plus 1 by 20 whole cube and so on. It is like this. So then I put a common 1 by 20, 1 by 20, 1 by 20 always. So basically, here it is more clearly done. So I tell you what I am doing basically. 1 by 19 becomes my 1 by 20 1 plus 1 by 20. One plus 1. You can write down the steps also. Into 1 plus 1 by 20. That way. It goes endlessly. You go endlessly. Dot, 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 dot. Close all the brackets like this. Okay, understand? This I have written here. Instead of 10, instead of 10n, you put it 20. So this becomes 20 minus 1 by 90. So 1 by 19 is equal to 1 by 20 into 1 by 1 minus 1 by 20. Is it therefore? So it's 1 by 1 by 20, 1 minus 1 by 20 to the power minus 1. And 1 by 20 is less than 1. So in 1 by 20, 1 by 1 plus 1 by 20 plus 1 by 20 square, 1 by 20 cube. So 1 by 20. So 1 plus 1 plus 1 by 20, 1 plus 1 by 20, 1 by, that goes. So suppose 5 by 19. Suppose I do 5 by 19. This m is 5 and n is 2. So 5 by 20 is how much? 5 by 19. 5 by 19 is equal to 5 by 20 into, you start with 5. Instead of starting by 1, you can start, as well start by 5. 5 by 20, 1 plus, 1 plus, again 1 plus 1 by, not 5 by 20. 5 by 20 work is over. Then 1 by 1 by 20, 1 by. So this is the thing. Actually, this procedure, here, I told you that you are dividing by 2, but actually no, we are dividing by 20 actually. So by dividing by 20, because we are throwing it to the next decimal point. And whatever is that 1 plus unutilized, that unutilized part here, unutilized part becomes my next change digit. That is a 1 plus. That is the 1 plus thing. Okay. So this is the mystery behind that procedure. Why that procedure is working? Because it comes from this particular decimal expression. But you know, people knew that this binomial expansion of 1 minus x to the power minus 1, but they never thought that this particular procedure can be used as a procedure. This particular algebra can be used as a procedure for evaluating the recurring decimal. That is the wit, that is the super intellectual capability of the Vedic method. Or you can say that this particular person who did contemplation of these things and found that procedure. That yes, this particular algebra can be translated into a procedure which will shrink the requirement of 784 calculations into just 28 calculations in one line. This is the beauty of the Vedic mathematics in this. I should say that this one particular go will tell that superiority of Vedic mathematics over even calculator. Calculator will not display so many digits. 109, 1 by or something by 109 has how many? 108 recurring decimals. All the recurring decimals will not be produced. Never.
Shall we now, shall we go for closure?
Yes. Now tomorrow I'll do that where the challenges are there. I'll revise again this one.
Monday.
Something other denominators. Then I'll do that how if the denominator ends in 1, we have to
That is on Monday.
you have to multiply both denominator in by 9 and becomes very big. So 1 by 19, then my digit divisor become 18.
Okay. That we will do at Monday, na sir? Monday.
Monday, yes. In between, please practice these things.
Yeah.
So then what we do, we did another algebra. Then we'll discuss all these things on Monday. Okay, thank you. Namaskar.
Yeah.
Please go through the also presentation also. Please go through the PPT also and try to follow. Okay. Namaskar. Thank you.
Namaste ji. Jayashree garu, can you chant Pradhana, please?
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पौत्रिणः अधनाः सधनाः सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान्मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः सर्वे जना सुखिनो भवन्तु स्वस्ति अंడి ధన్యవాదాలు
ధన్యవాదములండి జయశ్రీ గారు. Now let's go for Janaganamana. I will sing. जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद. అందరికీ ధన్యవాదములు.